Thank you, everyone. Welcome back to the ANSI virtual event on standardization and the commercial space industry. We are going to now continue our program with our second panel, which is industry perspectives. And I will turn it over to Therese Jones. Therese.
Thanks so much, Jim. Hi, everyone. I'm Therese Jones. For those of you who don't know me, I'm the Senior Director of Policy at the Satellite Industry Association. I want to thank ANSI for inviting me to moderate this panel. As I'm sure many of you know, space traffic coordination management and orbital debris mitigation have been a huge focus of industry the past few years. So I'm excited to put together this panelist of wonderful industry representatives. So slight lineup change today. Jennifer Warren of Lockheed Martin unfortunately got pulled into a CEO meeting and is really sad that she won't be able to join us today. She's definitely been one of our industry thought leaders in space traffic management best practices, and I'm sure would love to engage with all of you in the future on this. We've got Charity Weeden, who's Vice President of Global Space Policy at Astroscale, Dr. Brien, Flewelling, the Chief Space Situational Awareness Architect at ExoAnalytic Solutions, Dr. Dan Ceperley, CEO and co-founder of LeoLands, as well as Mike Safyan, Vice President of Launch at Planet, joining us today. And I'll hand it off to Charity to start our remarks.
Thank you, Therese, and thanks to ANSI for putting together this excellent program today. It's great to be here. I just wanted to highlight that Astroscale globally also includes entities in Japan, the UK, and Israel as well. Together, we have a vision to provide a safe and sustainable space environment for the benefit of future generations. And we're doing this by developing the needed innovative technologies, advance or even establishing business cases, and informing international policies, best practices, and standards that reduce orbital debris and support the long-term sustainable use of space. Astroscale is proud to be a part of a number of industry groups that allow robust dialogue on a variety of items, including spaceflight safety, namely ESOA, UK Space, Space Safety Coalition, the AIA, CSSMA, and last but not least, the DARPA seed-funded CONFERS, the Consortium for the Execution of Rendezvous and Servicing, where our own group's COO, Chris Blackerby, has just been elected chair of that organization. CONFERS has developed recommended design and operational practices for rendezvous and proximity operations, and has submitted a proposal to ISO that is now being worked as draft standard 24330. Astroscale is also participating in the World Economic Forum Space Sustainability Rating, which is a unique effort to assign a public rating to operators' debris mitigation activities. All this to say, dialogue between stakeholders, especially in today's pandemic, is absolutely necessary to move industry best practices and standards forward. It is also necessary to have robust dialogue in both a domestic and global context. But action needs to follow the talk, and industry is in an advantageous position to offer iterative design and innovation for safe space operations. As a major stakeholder in orbit, industry needs to be just as forward-leaning in advancing designs and operations that support both economic and physical sustainability in space. Ground-based or space-based SSA and a suite of on-orbit services such as disposal support, debris removal of defunct massive objects, and life extension of satellite spacecraft that simply need more fuel will be the foundation for a new approach to STCM that involves commercial opportunities. Today, there are domestic policy and regulatory instruments that require updating. There are also international and intergovernmental high-level practices that require implementation at the domestic level. And as previously mentioned, there are several industry-led groups that will feed into these governmental efforts. So I see a swirl of global activity and dialogue that needs two things: traction and speed. Traction in the sense that practical and effective steps to mitigate debris can be agreed upon, as well as a visionary and globally accepted STCM by a wide swath of stakeholders, and the speed to match the urgency of the situation. So I'm going to pause there, and I look forward to all your questions. Thank you.
Thanks so much, Charity. Now over to Brien.
Good afternoon. Thanks, Therese, and thank you to ANSI for inviting us to discuss the various aspects of standards and how they touch on our different areas within the industry. I had struggled a bit in trying to decide what I'd want to talk about, as we could go in many different directions here. But I have a few remarks that I'd like to share as I see how standards impact the way we think about the problem as an SSA data provider. So space traffic is evolving, both in its constituency and in the activities represented by new space operations. We need only look to recent satellite servicing, resource extraction, and sample return successes for the evidence for this. Standards must evolve to keep up with the changing environment. We are seeing this as the government is increasing the diversity of organizations involved in contributing to the space traffic management problem. As new responsibilities are being embraced, we'll need to work together to ensure that there is sufficient infrastructure to support the evolving mission, both from a sensing standpoint, policy, and other types of mechanisms here. And we will argue today that more is needed. As an SSA data provider, we provide a service or product which enables the understanding of the observed systems, their behavior, and their interactions within this environment, with each other and with other hazards such as debris. It is important to consider incorporating data collected in the execution of these increasingly ambitious operations. As part of the consideration of updates to standards and practices as they meet to the evolving challenges. Standards have been based on the assumptions and in some cases common understanding of best practices. But in many cases we are defining new precedents and new activities. We don't have decades to get this right, so we should be making learning and trust building measures a part of our process. As these policies are being updated, and we are seeing an explosion of space traffic, many are opting for automation to be the solution to risk management and avoidance. I would caution that automation, while a useful solution, should not be developed on the basis of sparse data, which has been our approach historically. In the event that management fails and we require remediation, debris removal will help ameliorate some of the effects of a congested environment resulting from today's practices. But executing these types of missions well will potentially require new flight safety services above and beyond basic services associated with standards-based situational awareness. To this end, ExoAnalytic provides observation services in support of flight safety and mission assurance, and we are working to extend our capabilities for GEO-SDA above 10,000 kilometers and out into cislunar space. As we consider new standards and update our policies, we should keep in mind many of the lessons learned in lower orbits and think about how they will impact us as we take the economy into deeper space. I appreciate your time and look forward to your questions in the discussion.
Thanks so much, Brien. And up next is Dan.
Thank you. Thank you. My name's Dan Ceperley. I'm the CEO and co-founder of LeoLabs. To quickly introduce our business, LeoLabs is the commercial platform for space traffic safety and space domain awareness in low Earth orbit. So as we all know, there's business revolution going on in low Earth orbit, and that's what's driving a lot of these discussions. So LeoLabs was founded to aid the new deployments, the growth in that industry. And the growth is quite impressive. About 4 years ago, there were approximately 400 active satellites in LEO. Now there are over 2,000, and there are tens of thousands slated for launch over the next few years. And looming over all of this is debris. There are about 14,000 pieces of debris tracked in LEO today, and that's only the large stuff, the 10 centimeters and larger. And as JC Liu mentioned earlier, there's a lot of smaller pieces of debris that are potentially mission ending. And if you look down to 2 centimeters in size, the number actually grows to around 250,000. So that means 95% or more of the risk is not tracked today. So when we look at this new revolution, the growth in the space industry, we see one big problem, a lack of data. There isn't enough information about actions and activities in space, and that's the challenge we're focused to solve. So our business is built on 2 technical platforms, a radar network and a data pipeline. So we build and operate phased array radars on the ground. We have 3 in operation today, and we'll complete 3 more in the next year or so. And we build these rapidly. We go from breaking ground to delivering data in less than a year. And we build S-band radars specifically focused on tracking objects down to 2 centimeters in size. We also run a software platform that analyzes this data and gets it in front of operators and analysts quickly so they have actionable information. There are a number of trends sweeping through the industry that we're keeping our eye on. Larger constellations and more frequent deployments. That's how we get full coverage in LEO. And it's also accelerating the pace of technical development, technical advancement in these satellites. The second is automation, and this enables flying large constellations and managing these constellations through all elements of the satellite life cycle, from launch and early operations through mission and service delivery, and then finally to deorbit. Another big trend, the third, is modern computing architectures are finally being adopted by the space industry. And this enables the industry to handle large data sets, provide real-time services. And these are architectures that were pioneered first by the computer industry for all the online platforms that we're all used to using today. And then finally, standard interfaces for SSA data are really moving into orbit. And what I mean by that is the most useful information for satellite operators and regulators and insurers are things like conjunction alerts, maneuver alerts, and the like. Most organizations don't want to be experts in radars or telescopes. And so the focus on simple measurements, radar measurements, and optical measurements is going away. So we're watching these trends closely because they're driving the large constellations and the advancement of the state-of-the-art in tracking services. So I'll pause there and just want to say thank you to the organizers, Jim and Therese and ANSI, for putting together a great discussion and extending the invitation to participate.
Thanks, Dan.
Thank you so much, Dan. And last but not least, we've got Mike.
Greetings, everyone. Mike Safyan. I'm the Vice President of Launch and Regulatory Affairs at Planet, and we are a company headquartered in San Francisco, California, and we design, build, and operate the world's largest fleet of remote sensing satellites. And our particular focus is around small satellites, and we have 2 active fleets. We have SkySat satellites, which provide high-resolution imagery, and we have 21 of those flying in low Earth orbit. And we also maintain a constellation of Dove series satellites called the Flock constellation, where we maintain over 100 of these small satellites that are about 5 kilograms or the size of a loaf of bread that are operating in low Earth orbit. And those 2 fleets, they operate in the range of 400 to 500 kilometers, so the lower end of low Earth orbit, and they have different methods of maneuvering. So the SkySats carry onboard propulsion and utilize that for their on-orbit orbital maintenance and also the occasional collision avoidance. And our Dove series satellites are able to maneuver using a technique called differential drag, where because we're low enough in orbit, there's enough of an atmospheric force from drag, where if we rotate the satellite depending on its orientation facing the velocity of travel, we can either minimize or maximize drag force and use that as a form of maneuverability. Space safety and safe debris mitigation has always been a part of Planet's mission, and a big part of that is continuing to launch our satellites to these low orbits, such that the total lifetime in orbit is in the handful of years. So we're in this region that can be considered a self-cleaning region of low Earth orbit. So we don't need to deploy active deorbiting end-of-life maneuvers. We can rely on the drag force to decay the orbit down and the satellites burn up in atmosphere. And recognizing that we do deploy and maintain so many satellites in low Earth orbit, we make sure that we're trying to lead the small sat industry and operate by example for how we think we can maintain a safe space environment, which also includes very openly sharing our positional satellite information. I think that what was already mentioned earlier in the panel is that good and accurate data is such a key part of maintaining space traffic. And so when we have better information about our satellite's location, we share that with other operators so that operators can accurately assess what is a real conjunction threat versus what's a false positive, and kind of cutting down the noise on a very noisy and uncertain data set otherwise. So with that, I'll pause and look forward to the rest of the discussion.
Thanks so much, Mike. I think this is a great question to kick off our discussion. If you had a magic wand and could fix one aspect of orbital debris mitigation and space traffic management, what would it be for all of our panelists? And I'll start with you, Mike, since this was your suggestion.
Sure. Yeah. So this is one aspect that I've been thinking about a lot lately, and that's this level of uncertainty around the position of different objects and also location of objects, especially very small objects. When we're looking at potential conjunctions between objects, oftentimes the uncertainties or the errors can be on the order of kilometers, where you're not sure. You have a probabilistic sense of a high probability that it's somewhere within this bubble or in this ellipsoid, but you don't really know. So you end up having to either kind of cross your fingers and hope that nothing happens, or you can make a maneuver, but you have to make a maneuver in some cases on the order of kilometers, where if you had perfect understanding of where everything was in orbit, then you could filter out all those false positives, and you really only need to do maneuvers on the order of tens of meters to avoid collision. So I think that satellite operators more openly sharing their high fidelity satellite position, more ground-based and space-based sensors so that we can get a better sense of where everything is, and also better atmospheric models so that we can better predict how these objects will travel in the future. And finally, more transparency around active maneuvers that operators are doing. You can get a very good sense of where an object is, but if that satellite is going to do a propulsive maneuver and you didn't know that, well, the very accurate modeling software that you have doesn't mean anything, because now they moved in a way that you didn't expect. So I think that as we get closer to quote unquote perfect knowledge, the easier it is going to be to wade through what's otherwise a very noisy environment.
Good. If I could,
go ahead, please.
Excellent. If I could dive in, Therese, wanted to build upon Mike's comments. I completely agree with him that at the moment there is simply not enough tracking, and in fact, he made a very interesting point about the small debris, that even by just tracking more small debris, that doesn't necessarily improve the situation. You have to track it, and you have to track it well so that it's actionable, so that the amount of uncertainty is small enough that a satellite operator can respond and keep their satellites safe, and not just spend every day, all day maneuvering, rendering the satellite useless. And that goes to a notion of transparency or traceability, that when information is provided about the location of a satellite or a piece of debris or a potential collision, that it's also accompanied by a lot of metadata. So how much information, how much data went into those predictions, how recently was that collected, what are the accuracies and the biases and the uncertainties in the sensors and in the processing. And that's not really something we've seen before. That's kind of a wave that's just starting to take over the industry. So I think all those considerations are quite important. And it also goes to addressing one other concern that often comes up in the industry, and that's the concern that, well, what if there are multiple opinions about a specific event? How do we get to the bottom of that? And in the past, there's only been the taxpayer funded public service available. So it's been kind of the only opinion or information about a specific event. And we're starting to see more services come online. And I think this is a really good thing, because for any given event, there may be multiple opinions, there may be differences of opinions. And what you need to do is look at the metadata associated with those opinions to really understand the quality of the service and ultimately act on the best information that's out there. So none of this talk of kind of merging data sets or fusing data together. you really don't want to take, say, bad data and good data and mix it together to get kind of a poor result. You want to take a close look at those quality of service metrics and really decide what information is the best about this specific event and act on that.
Thanks. Brien or Charity, anything you want to add?
I'm happy to go next. But first, I want to say, Mike, that's not fair. Just one thing I could fix with the magic wand. There would be many. But I'm going to actually definitely agree with both the previous speakers on, the needed data that's required for space situation awareness and understanding. So taking that data to actionable information is vital. But what I would rather press forward more firmly is the speed of agreement and adoption of the right amount of debris mitigation and remediation. I think this is a very difficult problem to solve worldwide, globally, and getting all actors on board instead of just having one nation, conducting most of the debris mitigation and others not following suit. So I think this is a vital thing. The speed of it is really important. We don't have a decade to wait.
So I will agree with my colleagues here on all previously stated points. The abundance of data necessary to support decision processes and collected at a rate necessary to support those processes necessitates a different approach rather than limping along the way we've done it in the past. And so if I had a magic wand that could move certain barriers to doing that, I would empower those who are able to contribute to do it in a way to build the necessary infrastructure to go solve this problem, as opposed to just limp along the way we've done it in the past. More sensors, realize what it takes to scale to the problem of today and the projections of the problem of tomorrow. The way we built the systems that we've learned from and that we've retired a ton of the risk associated with establishing the original mission is been called out in SPD3 as being insufficient going forward. And that's not a bad criticism. It's we need to address this problem for what it is. It is a massive problem. It is hugely important, and we should go put the investment into fielding the infrastructure necessary to support this domain and not pretend that it's okay to continue to address it as an extension of the approaches of the past. I think everyone's got a different approach or a different aspect of what we're trying to say about that. There are solutions out there, and whether it's policy or just resistance to change, I would use the magic wand to remove those barriers and to empower those folks to bring those solutions forward to get it done.
Thanks. And I definitely did want to get into, what shared understanding of risk is and steps we can take to improve this understanding, which a lot of you talked about. But also, we talked a lot about the technical steps that we take to improve this. Are there any non-technical steps that we should be taking in addition? What are the current biggest obstacles to coordination between operators receiving conjunction warnings? And what's needed on an international level, not just US level, to move forward in improving coordination?
If I could dive in, just a first round of thoughts here. I think one of the biggest issues about, say, international coordination is a common understanding of the risk environment in these orbital regimes. There's been a lot of really good work on statistically understanding what's the likelihood of collision, how's that growing over time, but actually shifting to actionable information based on detailed tracking and detailed risk analyses of all the conjunctions that occur over, say, a month or over a year is a great platform for constructing, say, evidence-based policies or actually serving as the foundation for communication for satellite operators around the globe. I think it's also a very critical element of the active debris removal industry and the development of that. It's a piece of the toolkit that's missing today, but with a much better understanding of the detailed risks that are being faced and broken down by things like altitude, inclination, that'll enable us to make the collective community to make very wise investments about how to bring that active debris removal service and technology to bear. So, right now there's kind of three things you can do about debris. You can avoid creating in the first place, you can track and avoid it, and then third, you can clean it up. And we're doing kind of the first two, and we really need to be doing the third as well.
Sorry, Brien, do you want to go? All right, I'll take a stab at this one. I'd like to, focus a little bit on transparency, and what has been the norm over decades is not to be very transparent in orbit. And I think this needs to change radically, and it is in a way. With more congestion in orbit, you're seeing more operators being willing to reach out. But I think it was brought up earlier this morning of, are operators willing to disclose maneuver plans or disclose ephemeris or provide, publicly information about their operations. So I think moving forward in transparency is one of those obstacles. And then, looking at, the government side of this, it certainly hasn't been transparent over, many decades before. And with the advent of things like spacetrack.org, that's opening up as well. So it's coming, but it needs to change towards more of a norm of, going out there, being transparent with your orbital neighbors.
I was just going to add that, risk is the convolution of the likelihood of an event of concern and the consequence of that event. And so, for operators, it's a difficult environment to operate in. And so the risk may be to your system. It may be to your bottom line, because you have to expend resources. Fuel is scarce, and Charity brought up the point of, refueling has only become an option only recently, and we're all still working toward that as a goal. So how you fly, if you can fly more efficiently than another business, that matters in terms of your ability to succeed or fail out there. And so there's naturally some good reasons why information is protected and should be. I think also, as we begin to assess the risk, the consequence side could be, you asked Therese for a non-technical thing here. The consequence of failing to continue to have safe operations in space impacts more than any one entity. Right? The economy is very interdependent on space services in different ways. And so being able to quantify, if you get this wrong, what is the impact, not just to the one system that was impacted by debris, but throughout the rest of the economy that depends on it so much. And that has many facets.
Okay, we got a good question from the crowd. The current de facto standard for flight safety in the industry is spacetrack.org. I'd like the panelists to comment on the usefulness of spacetrack for their businesses or the challenges and limitations they face based on spacetrack.org data and service quality, and then combine that with in what ways can commercial data be used to help end users verify applications of standards and operations of satellites, and just how can commercial data supplement what currently is out there.
Very good. If I could dive in, Therese. The spacetrack.org is certainly established a standard, which is the conjunction data message, and kind of additional standards around that, or norms, which is receiving data messages about 7 days before the time of closest approach, and receiving multiple messages leading up to that time of closest approach. I think all of those are really good. However, going forward, there's a number of things that need to be improved. One of those is the responsiveness or interactivity of the system, that at the moment there's primarily a one-way direction of information, just alerts coming out. But the ability for satellite operators to interact quickly with a system and experiment with proposed maneuvers, do risk assessments for what a potential maneuver might do is quite important and something we've been very focused on. We have a system now that within seconds can get answers back to satellite operators. If I execute this maneuver, what new conjunctions might I create? How does that minimize the risk of the conjunction that I've got my eye on today? So the other thing is it needs the collision avoidance service needs to be more comprehensive. So at the moment, it's very much focused on active satellites. It's focused on large debris, 10 centimeters and larger, but the small stuff far outnumbers the larger debris, the larger satellites. And so extending the catalog, bringing those small objects into the mix, into the calculation is going to be quite critical, because the active on active conjunctions, they get a lot of attention, but they're actually less frequent, much less frequent than threats caused by that debris.
I think, you know, to reference the audience member's question about spacetrack.org, you know, I think that's representative of the basic services that are being described by SPD3. And, you know, our goals are to be, you know, more timely, more accurate, more current if we can. As we were discussing this recently, it really depends sometimes who has the most recent data. And it doesn't really matter whose system it is. Having a multiplicity of systems that can provide you those reports, and you know, either those systems are more often correct, more accurate, more often, and you can do that assessment independently if we have independent systems that can verify various reports, you know, or you know, they're based on kind of more of a more frequent measurement paradigm than can be done with fewer sensors and the like. So, you know, spacetrack.org is representative of 18th Space Control Squadron and what's going on into the open catalog. But, you know, if anyone has more current data, there's always a lag, or, you know, we may characterize this as a difference in opinion, but you know, needing to propagate to the same time and understand what went into those estimates so that we can compare them fairly is important. I think Dan's point about metadata and the like, it is an important one for that. So, you know, I don't, you know, there are those who would like to see us move to a more competitive paradigm where we're always kind of pushing ourselves to provide the most current and most accurate solutions so that we can be, you know, pressing ourselves to do the best we can for the different operations we support.
I wanted to jump in with respect to the small object debris. I think that for large objects that already are in orbit and are already presenting a threat, I think that active debris removal is a really important part of that remediation. And I think, you know, Therese was asking about non-technical solutions. I think a big one in that realm is funding. And I think that governments should be spending a lot more resources funding both their own efforts and commercial efforts to be able to go out and remove, you know, like the top 50 most dangerous objects that are already currently in orbit. With the small objects, I think that puts the industry in a bit of a pickle because there aren't, you know, well understood and reliable methods to go out and clean up small pieces of debris. And again, you know, there needs to be more tracking so that there's more awareness. But that's a harder problem to solve. And you know, the best way we can do that is to try as much as we can to avoid making creating those sources of small debris. And you know, a great example is you know, a ban on anti-satellite tests. I think that it's really irresponsible when governments are intentionally blowing up their own satellites, regardless of what orbit it's in, which creates those small pieces of debris. And that's just adding, you know, more junk in a place that we don't need it. But as what's already existing in the ambient environment, I think that's a tough one with small debris, and I haven't really seen a great solution come out of the industry yet.
I'd like to piggyback on what Mike has just said, and I note that this morning it mentioned that priority is the prevention of small pieces of debris, and that's very important. And the way to do that often is to make sure that large pieces of debris don't become small pieces of debris. And that's where the remediation case comes in. And then to follow suit of the last question, what's the value of space track? A lot of operators, it's free and it's accessible. And that's hard to compete with, to be honest, when there are other services that cost. But the more that operators place a value on clean orbits, the more they're going to need additional support for space situational awareness. That could be increased timeliness, increased accuracy of understanding orbits and debris, or even characterization. What's my satellite doing? It's, it busted down and is it tumbling, et cetera. So these additional SSA services are going to cost, and I feel that operators need to build that into their necessary operational cost for the lifetime of an object.
Thanks. And we'll get more into the economics of this a little bit later in the discussion. I wanted to follow up on the data portion now. So particularly for the SSA data providers, what are the biggest technical issues that you foresee as we hopefully get funding for a civil open architecture data repository in the U.S.? For operators, what are your biggest concerns in interfacing with the OADR? And one of our audience members asked, operators have best information on disturbance torques and drags that affect orbit determination. Should they be forced to share this performance data in something like the OADR?
So I'll start from the operator's perspective. I think we've always taken the position that the more data, the better, the more that we can share our experience and what we're experiencing with our own satellites, with government agencies, with other operators. I think that generally creates a safer environment. And so, yeah, with the OADR, we think it's a great step in the right direction. We assume that there will be some hiccups along the way in terms of implementation, but this is a service that's needed, and I think that this is a solution that I think and hope will snowball, because it can't just be commercial operators all talking to each other, but we're missing out on government operators as well, and then also international operators and different elements of the space industry. So with rocket launches and upper stages of rocket bodies and what happens to those objects once they're done with their missions, there are so many different players, and we all have to be talking to each other. So the more we move towards shared data and better coordination, the better.
Dan or Brien, would you like to weigh in from a data provider perspective?
I'll take a stab. I think you had talked about some of the technical challenges associated with providing, value-added services for SSA and flight safety here.
We needed a data-rich environment.
I'm not sure what happened there. Brien, why don't you continue, and then we'll move on to Dan.
Okay. So I would say, and hearing what Dan's words were beginning to say there, moving to a data-rich environment were the last words that I heard. And while I agree, from a commercial services provider standpoint, it's always trying to move to a high quality of service product, right? It's always trying to, move to information that can be relied upon by owner operators, because it all comes down to the amount of human decision time that's available to be able to do anything about what we might think we see. In LEO, the time is definitely very short because the mean motions are faster for those satellites than any other satellites we might discuss. For the objects we see at GEO, there may be some more time, but it turns out a lot of the conjunction data messages and a lot of the information being provided is just too uncertain to warrant anything. So collecting more data helps us control that much more, in a much easier sense than it would in other parts of space. And then as you go further out, the challenges are immense. We need to see more sensitive. We need to see more persistently. We need to see 1,000 times more volume, like I've got kind of showing on my background here. And so we're talking about taking these capabilities and contributing so that they're available as, space operators do more than just operate in LEO, MEO, and GEO. And that's certainly upon us. So I say there's a whole host of technical challenges associated with that as well.
Thanks. And on to Dan. Hopefully the audio will work this time.
Yeah, sort of to build on what I was saying before, the real aim here is we need to move to a data-rich environment. Traditionally, we've been in a pretty sparse data environment where maybe we get an update every couple of days or at most a couple times a day. And that makes it really challenging to, say, automate collision avoidance systems, to add AI machine learning into the mix, and really achieve the scale that's required to keep up with the space traffic safety challenges that are coming with the new environment. So, that means larger constellations of sensors on the ground watching space. It means bigger data pipelines in order to get that information into actionable form and in front of operators in a very timely manner. So I think from a SFA data provider point of view, those are some of the big challenges, and I think industry is stepping up quite well to address those. Turning to the topic of the open architecture data repository, I think it's important to consider the difference between the architecture and the actual implementation. So the architecture is really focused on things like specifications, data types, interfaces, and the like. And then when it comes to implementation, that specific consideration is what is on the market, what systems are delivering services and are actually available to implement the specifications and standards set by the architecture. And, for the first time, we're now seeing multiple implementations on the market. In the past, there was essentially a monopoly from the public service. It was the only provider on the market, the only source of information about services out there. And we're now seeing multiple commercial implementations come into the marketplace. And I think it's really healthy. It'll drive innovation. It'll drive this state-of-the-art forward.
Thanks, Dan. Now I'd like to move on to more of an operational perspective. So there are 120,000 satellites that have been announced to launch by 2029. May not get that many, but it should still be tens of thousands. So what do you think the milestone industry standards or best practices are regarding satellite constellation design and operations that we need to develop to get there without ending up in the Kessler syndrome? So high level, what do you think we need to do in the next decade?
I guess I'll take this one. So we had a bit of what we would like to see immediately in our response to the FCC's further notice of proposed rulemaking, and that is to agree on the way to measure risk. It might sound like a very simple thing, but it's not. There's not agreement there, and we'd like to see regulators assessing risk based on the the aggregate or the entire constellation's risk profile. So that's number one. Number two was discussed this morning that, the 25-year rule, it doesn't seem reasonable that that's an appropriate level anymore in this new modern way of using our low Earth environment. And it might not be, a longer-term solution to bring it down to 5. It's more of a short-term and medium-term way to deal with the congestion, because when you need to maneuver, that reduces your service capability to your customers, and this could be actually an impactful thing on the economy or the space economy itself. So bringing end-of-life deorbit timeframe down to 5 years, as soon as possible actually, but no more than 5 years would be a prudent next step.
And I'll quickly say that once we get to very large constellation sizes, I think that those types of systems need to be held to higher standards, especially when it comes to reliability of their platforms. So, a system that is 95% reliable makes sense if you're launching a handful of small satellites, and there's reasons why that makes sense for keeping costs down and allowing for innovation with different experimental satellites or academic and research satellites. But when you're talking about thousands of satellites, a failure rate in the handful of percentage ends up being really significant. And, I think that OneWeb was a great example of a operator taking that type of scenario planning into account and saying, okay, we're trying to build our satellites as reliably as possible, but in the event that there's a failure, we're going to make it as easy as possible for some sort of active debris removal system to be able to clamp on to a special holder that we've designed, or easier to detect the position of the satellite with retroreflectors or things like that on the satellite body. So I think that there does need to be a higher level of standard applied to these very large constellations, because even small percentage failures or unexpected outcomes can have a really large absolute impact.
Dan or Brien, would you like to add?
Sure. If you looked at the problem of trying to safely fly up to the 120,000 satellites that you mentioned as a kind of a distributed control problem, right? It would be easier if one entity owned all of those satellites and knew everything and was all-knowing, but we have these interfaces between us because we all collaboratively have to figure out how to do this together, which introduces some communications lags and some other things that complicate that process. And there's a lot of those folks who want to go and, again, like I said earlier in my remarks, try to solve this with automation, because if we can standardize all those processes and take the human out of the loop, then that makes us feel safer that they'll make better decisions than perhaps we would with the limited time we would have, given just how frequent and often those satellites may physically or in an RF sense interact with each other in potentially detrimental ways. In any case, those control problems get very challenging if the decision processes are being made in the absence of accurately measured information and states. They have to make those decisions on the basis of somewhat realistic representation of what's actually going on with those spacecraft. And one thing, if you haven't tried to track objects that maneuver before, a lot of the orbits that are fit, a lot of the models that are used to predict where these things are going, assume that maneuvers are not occurring. That they are, objects, whether they're drifting in the drag environment or moving along with some sort of long period orbit fit. And the frequency with which you need an update on the basis of new data has to be faster than the rate at which the objects you're trying to safely control are maneuvering. So now imagine you have 100,000+ spacecraft that are all maneuvering at different times. If you're not coordinating when those maneuvers are happening, if those aren't on the basis of some projected plan, and they're a surprise to people who are providing data and then trying to use that data for a decision process, you've inserted so much uncertainty into the problem that it is intractable from the start. And so everything that we're talking about, from coordinating these things ahead of time to working with our launch states to saying that this is the way we intend to operate these systems in this test environment, to making sure that the data can incorporate them so that when they're presented to a decision maker, be it an operator or a regulator or other analyst, that you can do so on the basis of what you've assumed to be true about it actually is. Because if all of those things are left as variables, there are too many solutions to the problem that the data can't help you sort out.
Dan, anything you'd like to add?
Yeah. One thing just to build on what was previously said, I think some of the discussions or comments were kind of adding up to there's a need for kind of standard around reporting or around risk reporting. And, if there were kind of standards for what does the risk environment look like today, what is the specific risks a constellation faced, and what did they do about it, that'd be a real good basis for establishing audits and really keeping an eye on actual activities that are occurring in orbit. So a lot of the kind of regulatory focus today is prior to launch and making sure plans are in place, but there's very little follow-up in orbit. And I think that as space and especially LEO becomes more heavily trafficked, there'll be a need for more detailed follow-up. And without some standards around reporting, there'll just be a lot of uncertainty, and it'll be quite difficult to get a handle on exactly what's changing and what's being done about it. So I think that's one area we could really focus on. And an organization like the Department of Commerce would be very well positioned to take on that role and really use the reports that are coming out to understand maybe what sort of policies need to be enacted or improved, or frankly, where best practices are working quite well.
Thanks, Dan. So sort of along the lines in terms of, monitoring satellite health, particularly in the early operations phase, right after launch and deployment, has generally been a challenging time for satellites, potentially lots of failures, difficult to track satellites immediately upon launch. What are best practices that might address that challenge?
Well, yeah, I'll speak quickly from finance perspective, and other panelists can join in. We have a low-speed UHF radio that we've actually open sourced for the small-sat community that has been 100% successful on first contact and identification of our satellites, which also includes a radio ranging functionality, which can help narrow down the position of the object as well, because you do end up with a lot of confusion, especially right after launch, where you have a big cluster of several satellites coming off of the same deployment. And so that's one option. There have been other discussions around RFID tags or other types of quote unquote license plate on orbits that either can be integrated into the system or operate independently on its own limited battery supply, so that it doesn't rely on the functionality of the host satellites to still be able to identify and help track the object. I think that there is some element here of what a launch provider can do to help differentiate objects with how the deployment sequence is designed. So you might actually need more performance and more precise timing and deployment from an upper stage than a launch provider might prefer, because they're used to just delivering one satellite, initiating the deploy signal, and then their job is done. So there's some additional risk if they have to coordinate deployments over a large portion of an orbit or several orbits, and do so in a way that helps differentiate those objects. But I think one of the takeaways from all these discussions is that it has to be a industry-wide or group effort. So launch providers need to be able to provide upper stages that can help differentiate those objects through carefully designed deployment sequences, and also avoid recontact and collisions in those early orbits as well.
If I could dive in for a moment, building on what Mike said, Mike was focused a lot on the launch providers. I would also put a lot of emphasis on the ground systems here. One of the challenges today is that in the public service, there can be weeks to a month of uncertainty about the tracks on all of the payloads that have come off a single rideshare launch, cross-tagging and the like. And, as the number of satellites scales up in LEO, you really can't tolerate that amount of time with that amount of uncertainty. It puts a lot of risk on the satellite operators. It puts a lot of risk on the space environment. And that's where an entirely new generation of SSA systems is quite critical. You need to be able to acquire the launch and all the payloads very rapidly, within an hour after launch. And you need to be able to produce accurate states on all those payloads just as quickly and get that in the hands of the operators so they can get in touch with their satellites, so they can bring them into operations. And this is an area that we've been heavily focused on. We recently announced that we've been supporting SpaceX and the Starlink constellation since March with LEOP, Launch and Early Operation Service. We've also supported Planet a few times in the past. And it's just an area where we believe that the timelines need to be dramatically reduced so that as we get larger and larger launches, as we get larger fleets of satellites, there's just no uncertainty. We got to take all the uncertainty out of this process.
Thanks. Brien, anything you'd like to add?
Just a suggestion that these types of very focused services also represent some level of, as Dan characterized it, long duration and dedicated efforts. And in a question that is that really a basic service, in the sense that, as things are operating in steady state, let's say, and spacecraft operations are going on, I'll characterize it from the perspective of watching GEO with optics. Most objects in GEO you can expect to be trying to do some level of station keeping to maintain their slot and to provide their service. And things that don't do that either are having potential challenges in their operations or are not doing things that you would consider to be very standard of that environment. And in that steady state, getting a TLE every once in a while can be sufficient to avoid most things you would be concerned about. Higher precision applications are not basic services because they require an elevated level of use of your resources to derive a dedicated conclusion, and that is at the cost of supporting everyone else throughout the environment. And so just want to put the question out there in general of my own, which is, are those types of things that are non-standard and do require a dedicated amount of resources for an extended period of time that we're looking to innovate and improve on, do those fall underneath the purview of basic services, or are those considered value-added and advanced services?
Thanks. So I'd like to move on to financial incentives next. We had a couple questions along those lines. One from the audience: how do you balance revenue and profitability of your enterprise versus establishing standards that may limit it? And another that's sort of along the same lines: what financial incentives would your company see as a positive development in driving space sustainability? Charity, can I start with you?
Yeah, sure. Astroscale, I feel, is in a unique position here because we provide the service of space sustainability, but at the same time are an operator in space that must adhere to the standards and practices and regulations that are applicable. So we have to balance those two elements very carefully. But I can tell you that space operators will not be profitable if they're dodging debris all the time. So I think that's first in mind. But also on the other end, building and developing the technologies that help drive down the business or the cost of an end-of-life service or debris removal is also essential. So reusability is an important aspect that we're looking at very closely from our point of view. For the second question of financial incentives, there's two ways to look at this. For focusing on the government, we'd like to see increased government participation in debris mitigation and remediation efforts. Financial incentives not only help achieve the end goal of managing the debris population, but also encourage technology development and supports small and medium-sized businesses. So remember that also as we build out the space traffic coordination and management architecture, we are also concurrently building possibilities for sustainable exploration beyond Earth orbit. So there's a lot of benefits for the government to get more involved here. Industry, I feel industry needs to recognize the value of clean orbits, like I said before, that there is a value there, but it's not quite agreed upon what specific value is there or how to enforce it. So some ideas are being discussed right now, requiring insurance, indemnifying the government as long as there is a cap, fines or performance bonds. I think we want to see these economic incentives to be discussed and developed in a whole of government and industry dedicated group with a timeline to come up with agreeable financial incentives. So I think there's more dialogue needed here, but we need to come up with some sort of solution to make sure there are financial incentives to do the right thing.
Thanks. So maybe Mike, will go to you as an operator next.
Yeah, I think one of the aspects that I've seen evolve over the years is especially small satellite operators having a little bit more leverage with respect to negotiations with launch providers. I think that a little bit over a decade ago, you kind of had to beg your way onto a launch, and as a small satellite operator especially, and now the small satellite market is a very real and consequential element of launch business out there. And so taking advantage of that leverage to encourage good behavior with the launch providers as well. So, writing into your contracts that the upper stage has to deorbit within a certain amount of time. Otherwise, you won't take that service from that launch provider, or safer and easier to track deployment schemes. I think that that's one way we can use that influence to better adherence to safe practices, and sometimes that might come at a financial cost to the company. So a launch provider might say, yes, we can deorbit our upper stage faster, but that means that you lose 10% of the payload capacity you'd be able to use. And we'll make the decision that that's worth it for us because, again, like Charity is saying, it is in our both short-term and long-term interest for a safer space environment. So there, and I think that being part of these different efforts like the Space Safety Coalition, or the Space Sustainability Rating, this is just providing more fodder to say, hey, this is where the industry is moving. So if you're not going to get on board with that, we just can't work with you. And so I think that's one way where operators can maybe take a little bit of a financial hit because they're not using the full capacity of the launch vehicle, but they are promoting a safer environment.
Thanks, Mike. And as we're wrapping up the session, wanted to get some high-level thoughts from the panelists in addition to your general closing comments on, this effort is very, meeting is very U.S. focused. What needs to be done in addition to dialogues in the U.S. to achieve space sustainability, and what additional priorities have we not covered that you want to mention? So I will start with, I guess, Mike, and then I'll go through the rest of the panelists' closing remarks, what needs to be done internationally.
Yeah, I think that with a real kind of coalescing point has been the FCC's proposed rules around debris mitigation, and I think it's revealed a lot of questions that there hasn't been to date a strong understanding from both industry and government, such as, when you're thinking about a maneuver to perform collision avoidance, what is the minimum threshold that a meaningful maneuver needs to be able to actually avoid a collision? Or, what are the technologies we think are sufficient to be able to do collision avoidance? Or even, what is the probability of collision threshold where all operators should be acting? There are some kind of common practices, but there is some variation. And I think that, as been said earlier in the panel, a whole of government approach to define some of these things is really needed, because I think everyone agrees that we want a safer space environment, but when you get down to the actual details of what is a standard collision avoidance maneuver and what does that need to look like, there isn't a good sense, and so we're slowly moving there. But I think that, again, as been said earlier, there isn't a lot of time. The number of objects is proliferating quite quickly, and the sooner we get to industry understanding, the better.
Dan, how about you next?
Certainly. So, when I look at this, one thing I'd like to say just in closing is that data really underpins all of this discussion of best practices and requirements and policies and the like. And I think that's a really good direction for the industry to be going, that we can really start to craft policies, we can start to craft procedures around the actual activities in space. And even though the activities are increasing and the number of satellites are growing rapidly and the diversity of activities is increasing, we can actually keep up with that and start to have a faster feedback cycle and really fine-tune the procedures to keep satellites safe and hopefully keep the space environment fairly clean. One other thing I wanted to point out is that when you talk about price incentives, this actually even extends back to SSA data providers like LeoLands and I would expect ExoAnalytic as well, that for so long there was only a taxpayer-funded service, so there really wasn't competition out there in the open market. Now that we've started to see that market open up and we've started to see various service providers come into it, there is competition, there is a marketplace, and it's driving the state-of-the-art forward. And I think that's going to be absolutely critical in order to scale up the amount of data that's being collected, the speed at which is being reported. And without that competition, the data services are simply not going to be able to keep pace with the development of these satellite fleets in space. So with that, I really appreciate the opportunity to participate here.
Thanks, Dan. Brien, how about you?
I think I want to come back to the points on data and verification. Oftentimes when we talk about data in this context, it's do we have the right data or the timely enough data to help avoid this collision right now? But when we have the policy discussion and we talk about, are we following best practices? Are we doing these types of things? It's amazing what you can learn if you have the data at scale across the different objects in the space environment. The things you can learn about how all space objects in a domain you may be watching react to space weather, for example, or all the other things that aren't the original application for why you may have collected the data in the first place. And so when we talk about needing that infrastructure and needing that data to support flight safety, it's not just for the ways we've always done this, the data for collision avoidance sake. It's for all of the other questions we didn't know to ask, but now we should ask because we are operating in this environment differently. And that comes back to verification, which is whatever policy you define, however the policy is updated and involved, do we have the ability to verify that it's being followed? And if that's not the requirement for civil space traffic coordination and management, and it's on the basis of things like conjunction avoidance or other ways that we've expressed the problem in the past, I think we missed the boat and we will fail to scale to where we're going in the future.
Thanks so much, Brien. And then finally over to Charity to clean up all our debris.
So my final point here is really directed at governments worldwide that have been looking at this issue for decades, and to encourage them to continue, but also increase bringing industry in. Industry can bring speed and innovation to this problem. And industry has a global reach already. There are companies, multinational companies like our own and many others. There are industry efforts like Space Data Association that are global in nature. So there's a lot of promise when you incorporate industry into the dialogue, which has been traditionally governmental or intergovernmental. So would encourage governments worldwide, if you want to get to this problem quickly, get industry involved. Thank you.
Thanks so much. And I think we're out of time. So really appreciate all of you joining us and looking forward to engaging in more industry dialogues with government and NGOs. So thanks, and I'll hand it back over to Jim.
Well, thank you so much, Therese, and thanks to all of our speakers on the industry session. We'll take a break right now. We'll leave the meeting open, and we will resume at 3 p.m. Thanks, everyone.